from the College by the Lake, Coeur d'Alene, Idaho. Local, regional, national, and international guests discussing the issues and topics affecting the way you live are on Forum, the North Idaho College Public Forum, with your host and moderator, political scientist Tony Stewart.
For several months, you have been hearing almost nightly on the news something about El Nino and how it's affected weather patterns, particularly in this country. Even though you've heard that on the forecast, we plan today to bring you some more detail with a specialist who can tell us why this is happening and what happens each year. I'm very pleased to welcome to the program Bill Richards, who is a tenured faculty member at North Idaho College, and he's a geologist, and we've asked him to come to discuss what we think is very important and intriguing and how it affects your life in the weather currents. Bill, welcome to the program. You've been here before on other issues, and it's great to have a colleague here. We're very pleased. We like to show off our faculty to our viewers, too, in their expertise, and to assist our viewers in understanding in more detail some of the information that is helpful to them. Welcome to the program.
Thank you.
And as always, I'm very pleased to have Steve Schink on the panel. He is the Dean of College Relations and Development at North Idaho College, and as always, when he's here with me, he shall commence the questioning.
Thank you, Tony. Bill, I thought maybe we'd start with the basics. Even though we hear about El Nino frequently, as Tony said in his introduction, I don't pretend to understand it at all. And I thought maybe you could start by telling us a little bit about what it is and how it affects weather.
Well, basically, there's two conditions in the Pacific. Most of the time throughout the year, the normal circulation at the equator is from the eastern Pacific to the western Pacific. This creates a certain set of conditions. One is it sucks colder water up from deeper along the coast of South America. It piles hot water up against the continents over here, way over in Asia. So actually the ocean is deeper by about 40 centimeters on the western Pacific, and therefore a little bit less. The Earth's rotation magnifies this effect, because the Earth's rotating underneath the water in effect, so the water piles up. So most of the time you have very cold, nutrient-rich water upwelling along the coast. The same is true along the California coast, north of the equator, but to a lesser extent. El Nino occurs beginning in late fall and winter every year, where this process breaks down and the equatorial current flows from the west back towards the east. So it kind of sloshes back the water. Well, that doesn't allow the cold water to upwell along South America, and so situations just get reversed. And this changes then the airflow patterns, high pressures versus low pressures, and it reverses where they exist. And that's the main process. By spring, in February or March, the other conditions should return back to the Pacific, and El Nino breaks down until again the next winter. And that's basically the situation.
Great explanation of the physical effect of water and temperature and wind currents. Now, how does that translate into changes in the weather?
Well, based on those changes that occur, moisture in the air is going to be a function of the temperature of the water beneath it. And lower latitudes near the equator, if they're warmer, will have more moisture in the air. Colder waters, as is the norm along South American coast most of the year, would allow drier air. And so the climate would be mostly drier, and that's what you see along the Andes, is lots of high deserts. The geology there affects it as well, but the temperature of the water being colder, the air is drier, so you have lots of high deserts. When the air becomes warmer, there's more moisture, and it can evaporate more water out of the ocean. Therefore, anywhere that air goes, it's going to dump moisture, whereas other times of the year it would not.
Before the program, we went into some discussion about this whole process, and you've indicated that El Nino is with us each year, as well as the other condition, and you've even given somewhat of a timetable. I have several questions. First of all, that timetable is not identical every year, is that correct?
The span of time that the El Nino conditions exist may expand or may contract on a cycle of about every 3 to 10 years, or 7 to 10 years in there somewhere, the time span for El Nino will expand tremendously, and therefore the conditions will intensify. The last El Nino condition that was intense was in the winter of 82 and 83. So we're about 10 to 13 years beyond that. So some people try to put an intense El Nino effect in the winters of 91 and 92, if you remember those years. But it's about a 3 to 10 year cycle. And that's a pretty large span of time to try to predict when any one year will be more intense than another year.
But this particular year has been much different than recent years?
Obviously, the El Nino conditions began earlier, as was predicted, and that means then on the tail end of things, it's going to take longer for them, theoretically, to break down and go back to the other set of conditions. Maybe they'll break down sooner than we predict, maybe they won't. But their effect will be felt long afterwards, because the air still has to have time to cool off, the water still has to have time to cool off, go back to its other condition. So it may be a month or 2 or 3 before we really see the conditions in the atmosphere that El Nino can cause go away as well.
We've also talked about something called in our own terminology, the yo-yo effect, that there's been predictions throughout the last few months that the conditions were changing, or then they've expanded back again. Is this one more unpredictable in what is happening? And I know you partially just answered that, but what is happening? Can we anticipate that this program will not be airing until later, but we're taping it in late February? Do we anticipate that the late spring or summer may be different this year than normal?
Well, there's a very sarcastic saying that only fools and foreigners predict the weather. And not being either, I don't want to predict what will happen. The El Nino conditions are tied in with the amount of energy that's in the oceans and the amount of energy that's in the air. And that's a phenomenal amount of energy. Whenever water evaporates, it transfers tremendous amounts of energy. So what is all that energy going to do? When will that energy dissipate away? That's a hard thing to predict. Even our most powerful supercomputers have a difficult time agreeing on the model. Different investigators get different results when trying to predict the model. The computers can't even agree. You even give them the slightest little bit of difference, and they'll come up with totally different predictions on the length of span that El Nino has expanded into for this year and when it will break down. I plan to start my seedlings at the same time this year that I started last year, and I plan on being able to put them out a little earlier this year, I think. We had a fairly short El Nino last year. There wasn't any warmth carried into the spring. I think it'll be as we generally predict. I don't think we're going to see a protracted El Nino that goes all the way into the next cycle, into the end of next summer. I think it'll break down February, March, April, just like we are predicting, and then it'll be back again next winter.
It's kind of unfair to you. Here you predict in February, and the show is airing in May, and so you'll either be predicted right or wrong. But anyway, it won't affect the planning, because it surely will be done by then. But the point I'm trying to make is that we do hear a lot of mixed reactions about how we're going to even move into the rest of the summer and year. And with that, I'll move back to Steve.
Bill, at least from memory, it seems to me that the predictions, and we did have them early this year, that we were going to have and probably the thing I've learned that surprised me most already is that El Nino happens every year. I thought it was a phenomenon that occurred only every 5, 6, 7 years, but now we're talking about the degree of it. But they predicted heavier than normal rains on the West Coast, and that has come to pass. I think they predicted that one of the effects of El Nino would be a fairly mild winter in our region, the Pacific Northwest. How does it play out across the rest of the country, and does it have even larger global effects that we don't hear about because it doesn't influence weather in the United States?
Well, the Pacific's one of the largest bodies of water we have, and there's a tremendous amount of energy stored there. So certainly that energy is going to circle the globe before it totally loses its effect. So yes, it has an effect everywhere. But I could point out once again, the reason we had the wetter climate here on our west coast, and we still are experiencing it in California, was normally this time of year high pressure should prevail. However, in El Nino, since things are reversed, we have lower pressure. Lower pressure will bring us more precipitation, more unstable air.
Storm
That's
fronts,
what we
yeah.
see. And since the cold upwelling has also broken down, that means there's warmer surface water. That puts more moisture into the air. So if the air is moving and it's unstable and it has moisture, well, that equates to precipitation. And that's where we get this precipitation. Instead of high pressure giving us more stable air, we have lower pressure giving more unstable air. That unstable air then could continue into other parts of the country.
Let me ask you a question that's certainly related to El Nino and right down your alley as a geologist. One of the effects of El Nino that we've watched on the news, on the nightly news, is huge mudslides in the California region, and I do know that is a problem on the West Coast. We hear about it in Seattle. I don't hear much about it here in the inland Northwest. Is that a function of less precipitation, different soil types, terrain differences? What do you attribute that to?
Well, you really answered it. It's a combination of all those things. We don't have the amount of moisture that the coast gets. We don't have the deluges that they get, the intense precipitation. We don't have the relief that they have, where you have very steep gradients with very low vegetation. In the California coastal areas, you have small scrub brush type vegetations on steep gradients, and when you have these gully washers, some people call them, and when they're intensified in an El Nino year, you can expect more runoff. More runoff will take more soil with it. It'll have a catastrophic effect of potentially causing landslides or mud flows. A landslide might not be as accurate, but debris flows that can cause tremendous amounts of damage.
Another geology-related question, where El Nino seems to be having its biggest effect along the coast, that it's also one of the most geologically active areas in the country. Lots of faults, lots of earthquakes. Are they related at all, or two totally different phenomena?
The two phenomena are unrelated. The terrain of the coast can be related to the faulting and the mountain building and the tectonic activity, and that then sets the area up for the potential for more debris flows and landslides when you do have an El Nino situation that's causing the trouble that it has. We're less active where we are here in Coeur d'Alene, and we have a heavier vegetation. Our soil's more well protected. We shouldn't see those kinds of events.
Now, and I'm going back to some of the information you gave us earlier. I've got to be told these things 2 or 3 times, Tony, before they really sink in.
That's 2 of us.
Okay. El Nino, is that the point where the water kind of sloshes back over, where that difference you talked about in 40 centimeter difference in height is lessening?
Correct.
Okay. So one of the other things I've watched on the nightly news is tremendous damage from wave action along the coasts. Combination of the storm activity and the fact that now our water level the water table has risen along the coast?
That's true. You've got more storm surge activity, plus the sea level will rise. It'll be a little bit higher. That can't account for everything, but the storm surges that are coming in with the prevailing winds now being from a different direction as well. That'll help pile the water up on this side of the Pacific instead of on that side of the Pacific.
And a final question in this series, if you'll let me ask it, and maybe Bill, you want to drag that globe back close to you and rotate it 180 degrees. Is there a similar pattern of activity that takes place in the Atlantic Ocean?
That's a very good question. That's an excellent example. It gives me the opportunity to show that effect really happens in every major ocean basin. In the Atlantic, the western Atlantic has water piling up against it, and you have cold upwelling in the eastern Atlantic. There's just not as much water here, so you don't have that much impact when when it breaks down. But the same events are happening. The general situation is for the surface water at the equator to be traveling towards the west. The rotation of the Earth underneath magnifies that, piles up the water over here, and then you occasionally will get some sloshing back. Exactly.
I lied.
That's fine. You go right ahead.
Are the water temperatures in the two major oceans roughly the same given their relative latitudes? In other words, I know the North Atlantic is cold. Well, the water over off the Seattle coast is cold too. Are the temperatures similar in the two oceans?
The models for ocean circulation are very similar between the Atlantic and the Pacific, yes.
Okay. So you would be experiencing some of the same effects in the Atlantic, but not to the extremes because the bodies of water are dissimilar. Thank you.
The average person on the street certainly has discussed this a lot, and we who are not like yourself, experts, professionals, that as winter has changed and from where we're sitting in the Pacific Northwest, we had a rather severe winter last winter with ice storm commencing the whole process, and a very long winter. I would say this might be the mildest winter that I have observed in all my years here in the Northwest. And you keep hearing everyone saying El Nino is responsible for this. And we've seen a lot of snow and severe weather on the east coast of the United States. We've seen even in the southern, the upper southern states, snow they usually don't get. And as you said, on the west coast, a lot of rain, and it's been very mild here. Is all this the reasons for, let me back up and say, does El Nino explain why that has all happened in the country? Are we blaming this particular development on everything or giving credit when it may not be the entire reason?
Let me say this about that. People who are much smarter on this than I will, in a few months, start sitting down at conferences and things and saying, okay, of all the climatological events that happened, which ones were due to the intensification of El Nino? And they will argue for months on that even. There is also another aspect to weather, that any event anywhere on the planet could affect the weather anywhere else on the planet. So to say it has no effect would, I think, be incorrect. But to say it's the cause of every event we've had, I think would also be incorrect. There's a concept that because the climate and the atmosphere of the planet is such a complex model, it could be that a butterfly in South Africa flapping its wings causes a storm over Texas. It's called the butterfly effect. And we don't know that it's not that one difference that's causing the supercomputer models to be different. So months from now, people will sit down and decide what was the actual effects of El Nino this year.
Let's bring another issue into this formula. We've heard a lot about the environment from international conferences dealing with such issues as ozone layer and its effect by certain things happening in pollution. We hear a lot about the destruction of the rainforest and South America. These international conferences debate this, and it's controversial, and there's more than one side of the issue. Is the planet becoming warmer? How would you react to those kind of factors that are separate and are more encompassing, regardless of which side of the issue you take, on the future of the planet, weather and resources and climatic conditions?
Well, they may be related. The intensification of El Nino may be part of many other things. The concept of global warming being one of them, but it depends on what perspective you wish to take. Even the reports that the conferences are seeing are changing. In the last 50 years, our estimate of how much the global climate may have warmed has plummeted. 50 years ago, we were estimating it's in the order of several degrees. Now it's less than 1/2 of 1 degree. So we're actually downgrading our estimate of how much the atmosphere has warmed, and it keeps getting lower and lower every year. So it's in the tenths of a degree now instead of many degrees. And if you look at another perspective, in a geologic perspective, the Earth as a whole over the last 500 million years, on average, is estimated to have been 9 to 10 degrees warmer than our current average global temperature. So if you look at the historical perspective, from a geologic point of view, we have 9 or 10 degrees to go before we're back to average.
What were how long ago?
For the last 500 million years of Earth's history. And this points to another global historical fact, that most of the planet's continents should be covered, most of them, by 100 or so feet of water. The ocean really should be covering most of the continents. For the last 900 million years of Earth's history, that's been the average.
Would you like to explain that? I'm going to let Stephen.
I'm just dying to jump in, because the other thing that occurs to me, Bill, and that I wanted to ask about, it's a little bit afield of what we've been talking about, but I wanted to pose it to you again as a geologist. The other, of course, huge cyclical phenomenon that has shaped much of at least the northern hemisphere is glaciation. And we've gone through a variety. I'm going way back to my old college geology classes, but tell us a little bit about the glacial periods. I mean, it's not that long ago that a good part of the United States was covered in ice, wasn't it?
Well, the last glacial ice age that could clearly be called an ice age ended 30,000 years ago.
Yeah, I say not that long ago.
Not that long ago.
In geologic terms, that's not
that long ago.
Is there any reason to believe we could not be in a trough, and that there isn't another ice age coming sometime in the future?
Again, if you look at the global perspective of climate history on the planet, we see many cycles of glaciation tied in with other cycles, sunspot cycles, the ellipticity of our Earth's orbit around the sun, the wobble of the Earth's axis. All of those cycles may have a play in controlling when we have pulses of ice volume. We actually don't need cooler temperatures to have global increases in ice volume.
Really?
We don't actually need warmer temperatures to have global decreases in ice volume. Temperature may be a factor, but it's not the only factor. One major factor, as El Nino kind of points out, is the availability of moisture to the air. If you put more moisture in the air, you're going to have more snow in polar regions. If you have more snow, that reflects more sunlight, so the ground warms up less. That causes more snow to stay longer, and therefore at some point you can accumulate enough snow to cause glacial episodes without any increase or decrease in global temperature, just a change in the moisture patterns.
Bill, can geologists tell us how quickly these cycles have flip-flopped? In other words, if you accept the premise that there could be another ice age in our future, is that something that would happen gradually over many, many tens of thousands of years, or does the process actually happen pretty rapidly?
Well, we do look at cycles, but pinpointing any one set of cycles, saying it will be 10,000 years or it will be 10 years, when, just like with El Nino, it's a 3 to 10 year window there where its time frame expands. Glaciation is the same. We know there's a cyclicity. We can't say it's every 100,000 years. We can't say it's every 200,000 years. I think we can say within the next million years, there's a likelihood we could see another small ice age. We have seen in the last few thousand years mini ice ages, miniature ice ages, where cultures that were inhabiting Greenland, farming in Greenland, they actually were living, growing crops, killed out by miniature pulses of ice, which we're still in the tail end of. The glaciers that are currently in Glacier National Park didn't make Glacier National Park. Those glaciers were gone 30,000 years ago. But about 4,000 to 5,000 years ago, there was this pulse of ice volume, and that's what the glaciers are in Glacier right now, is the remnants of those. So yes, we've seen little pulses. Is this a little pulse at the end of a big pulse, or is it a little pulse at the beginning of another big pulse?
So at this point, we're in the last phase of a receding period of glaciation. Is that?
I think we could safely say that. We're on the downward side of it. When does that turn and start to go up? Maybe we've already turned and started up.
So that it's really tricky here, trying to decide whether you want to move north, expecting a 10-degree increase in temperature to open up whole new areas to golf courses and
I wonder why you had mentioned golf.
Yeah.
Or move south, fearing that the next ice age is just around the corner.
But then you could golf all year.
Yeah, I'm going to have to work on this, Bill.
For our viewers who don't know, Steve, one of his loves is golf, and so I knew that we wouldn't get through this program without that coming in. That's fine, Steve. I want to go back to my question because I was so intrigued, and I know Steve and I both are so interested in what you're having to say, and time is always short for our curiosity on this program. But you indicated in my first or my last series of questions that, if I understood correctly, that we're out of balance, that much of the Earth should be covered in water now and isn't. Would you explain that more in detail?
That was just from a geologic perspective. If you look at the geologic history of the planet and you take the amount of time that the continents have existed, most of that time is occupied with at least most of the continent being covered by oceans of 50, 100 feet, some shallow oceans, some deeper oceans, with only the higher spots sticking up as little islands. And we know that
around the whole world.
Worldwide, that's correct. We're enjoying a time now with a huge amount of land mass exposed that is not the average for the geologic history of the planet.
And so this could be temporary.
So this could be temporary. What we see now is not the average and could be temporary.
So life as we know it could change. We have about less than 2 minutes, but we hear a lot about the life expectancy of the planet, and that would be one example. But is this planet going to wear out? Is it going to be not inhabited by life?
Well, that involves so many factors that we have a dynamic planet. I've read a book by tremendous author Stephen Jay Gould, who talks about if every single creature on the planet died, every cell of bacteria, every little blade of grass was totally gone, the Earth would still be here, and at some point, life would be back on this planet.
So we go through another evolutionary process of replenishing the planet?
Of some sort. It would not be the same, because you couldn't do the same thing twice that way. But the Earth is so dynamic, it replenishes many of its systems itself.
And it goes in that cycle of being covered by water and then also lots of land mass.
Correct.
On that note, we have to bring the program to conclusion. On behalf of Steve Shink and our staff, Bill Richards, we think it's been a very intriguing program, and we've opened up some questions. We'll have to have you back to pursue at another time on our program. Ladies and gentlemen, we certainly enjoyed bringing you this program, and I invite you to be with us again next week, and we'll discuss yet another issue. Until then, please have a good week. I am Tony Stewart.
The North Idaho College Public Forum was videotaped live from the studios of Instructional Technology on the campus of North Idaho College for viewing at this more appropriate time. We invite you to join us again next week for another all-new edition of the North Idaho College Public Forum on this public television station.